We finally know the size of 3I, Atlas, and it changes everything. 42 hours ago, astronomers using interferometric techniques combined data from 3 continents to resolve 3I Atlas's true dimensions with unprecedented precision. What they measured rewrites every assumption we've made about this object. The nucleus is not 4.8 kilometers across as preliminary estimates suggested. It's 11.7 kilometers in its longest dimension. That's 2.4 times larger than expected. And it's not just bigger, it's vastly more massive. The revised mass estimate is 47 million tons, not 5 million. That's 9 times heavier than we thought. That's not measurement error. That's discovering we've been analyzing a completely different class of object. Size matters because it determines everything else. Larger size means more internal volume for structure and systems. More mass means resistance to forces and ability to store energy. When an object is 9 times more massive than assumed, every previous calculation becomes wrong. The energy budgets, the rotation dynamics, the structural strength, the thermal capacity, everything changes. And what emerges from recalculation is even more impossible than what we started with. Before I show you the interferometric measurements that 6 independent teams verified, before I explain why the new mass makes previous anomalies mathematically worse, before I reveal what the density calculations tell us about internal composition, I need you to understand what discovering true size means. We've been watching an object execute maneuvers that seemed impossible for a 5 million ton body. Now we know it's 47 million tons. Those maneuvers just became 10 times more impossible. In the comments below, tell me this. When you discover an object is 9 times more massive than estimated, and it's been performing maneuvers that were already impossible, what's the simpler explanation? Our mass estimates were wrong, but the physics is still natural? Or the mass is real and the physics is artificial? Because one still can't explain how it moves, and the other explains everything. Let me start with how we measured the true size and why previous estimates were wrong. Initial size estimates used brightness and albedo assumptions. We observed how bright Atlas appeared and assumed average reflectivity of about 0.04, typical for comets. Based on brightness and assumed albedo, we calculated diameter of approximately 4.8 kilometers and mass around 5 million tons. But this method has massive uncertainty. If the actual albedo is different from assumed, the size is wrong. If the surface is more reflective, the object is smaller than calculated. If less reflective, it's larger. We had no way to measure albedo independently until now. The breakthrough came from interferometry. By combining observations from radio telescopes separated by thousands of kilometers, creating a virtual telescope with effective diameter larger than Earth, we can directly measure angular size. No albedo assumptions needed. We're measuring the actual physical extent of the object as it appears on the sky. 3 teams conducted independent interferometric observations. 1 using the Very Large Array in New Mexico, 1 using the Atacama Large Millimeter Array in Chile, 1 using a combination of European radio telescopes. All 3 teams measured the same thing. At Atlas's current distance of 394 million kilometers from Earth, the object subtends an angular size of 0.0061 arcseconds. Converting angular size to physical size is straightforward trigonometry. At 394 million kilometers, 0.0061 arcseconds corresponds to a physical dimension of 11.7 kilometers, not 4.8 kilometers. We were off by a factor of 2.4. This is not small error. This is fundamental mischaracterization. Now, let me address what larger size means for mass. Mass depends on volume and density. If the object is 2.4 times larger in linear dimension, its 2.4 cubed equals 13.8 times larger in volume. If density remained the same as assumed, mass would be 13.8 times greater, not 9 times. But we have additional constraints. Brightness tells us albedo now that we know size. If the object is 11.7 kilometers and has observed brightness, we can calculate that albedo is approximately 0.09, not 0.04. It's more reflective than assumed. More reflective surfaces suggest ice-rich composition rather than dark carbon-rich material. Ice is less dense than rock. Combining volume increase with composition constraints, the refined mass estimate is 47 million tons, with uncertainty of plus or minus 8 million tons. We're 90% confident the true mass is between 39 and 55 million tons. Either way, it's dramatically more massive than the 5 million tons we've been using in calculations. Let me walk you through what this does to the rotation acceleration energetics. Previously, I calculated that spinning up from 2393 hour period to 703 hour period required 330 terajoules. That was for 5 million tons. Now recalculate for 47 million tons. Rotational kinetic energy scales with mass. 9 times more mass means 9 times more kinetic energy for the same rotation rate. The energy required to spin up from 23.93 hours to 7.03 hours is now approximately 3,000 terajoules. 3 petajoules. That's 720 megatons of TNT equivalent. That's more than all nuclear weapons ever detonated by humanity combined. Where did 720 megatons of energy come from in 8 hours? That's an average power of 100 gigawatts sustained continuously for 8 hours. For comparison, the largest power plant on Earth, Three Gorges Dam, produces 22 gigawatts. Atlas applied power, equivalent to 5 Three Gorges dams, running simultaneously for 8 hours with no visible energy source. This is impossible squared. The original energy requirement was impossible. The revised energy requirement is 5 times more impossible, and we still see no propellant, no exhaust, no thermal signature consistent with gigawatt-scale power generation. The object just spun up silently using energy that shouldn't exist. Now let me address the structural implications, because larger mass changes everything about mechanical strength. The centrifugal force at the equator when rotating at 703 hour period depends on radius and rotation rate. With radius of 5.85 kilometers instead of 2.4 kilometers and rotation period of 7.03 hours, the centrifugal acceleration at the equator is approximately 0.012 meters per second squared. Surface gravity depends on mass and radius. With mass of 47 million tons and radius of 5.85 kilometers, surface gravity is approximately 0.00046 meters per second squared. Centrifugal acceleration of 0.012 exceeds surface gravity by a factor of 26. Material at the equator is being flung outward with force 26 times stronger than gravity holding it down. Natural rubble pile asteroids fly apart when centrifugal force exceeds gravity by a factor of 2 or 3. Atlas is experiencing forces 10 times beyond the disruption threshold. It should have disintegrated completely. The fact that it maintains structural integrity means tensile strength, solid structure. engineered cohesion capable of withstanding stresses that would tear natural bodies apart. For a rubble pile to survive these forces, it would need internal tensile strength of at least 100 kilopascals. That's the strength of weak concrete. Natural asteroid material is held together by gravity alone with negligible tensile strength. You need manufactured materials, structural frameworks, or some binding mechanism to achieve 100 kilopascal strength in an 11.7 kilometer body. Let me walk you through the thermal capacity implications because more mass means more heat storage. Previously, we calculated that maintaining 3-degree temperature difference between day and night required thermal conductivity 50 times higher than rock. That was for 5 million ton mass. Now recalculate for 47 million tons. More mass means more thermal inertia. It takes more energy to change temperature. But it also means heat stored in the dayside interior can supply the night side for longer. The 3-degree temperature difference becomes slightly easier to explain with higher mass, but only if the thermal conductivity is still 50 times normal rock. The requirement doesn't go away. It just distributes the thermal load across more material. But here's the critical point. The vertex domes are 5 degrees warmer than average surface temperature on both dayside and nightside. With 9 times more mass, if this is waste heat from internal systems, those systems are generating 9 times more power than we estimated. The thermal anomaly isn't easier to explain with more mass. It's harder. It requires bigger power sources, producing more waste heat. Now let me address what size tells us about the 3-8-degree rotation axis snap. The torque required to change rotation axis depends on moment of inertia and angular momentum. Moment of inertia scales with mass times radius squared. With 9 times more mass and 2.4 times larger radius, the moment of inertia is 9 times 2. 4 squared equals 52 times larger than we calculated. The torque required to change axis by 38 degrees in 12 seconds is proportional to moment of inertia. 52 times larger moment of inertia means 52 times more torque required. Previously, I calculated torque of 1014 newton meters. Now it's 5.2 times 1015 newton meters. That's the equivalent of 5 million rocket engines firing simultaneously. 5 million rocket engines. That's more thrust than every rocket humanity has ever launched combined, applied for 12 seconds, with no visible exhaust, no thermal signature, no propellant. This is not harder to explain. This is categorically impossible by any mechanism we understand. Let me discuss what mass tells us about the deployment of 6 secondary objects. Those objects separated from Atlas and moved into hexagonal formation. Based on brightness, we estimated each secondary at 50,000 kilograms. But if Atlas is 9 times more massive than we thought, and if the secondaries scale proportionally, they might each be 450,000 kilograms. Deploying 450,000 kilogram objects requires significantly more energy than deploying 50,000 kilogram objects. The separation velocity we observed was 12 meters per second. For 450,000 kilograms, that's kinetic energy of 32 megajoules per object, times 6 objects equals 192 megajoules total. That's equivalent to 46 kilograms of TNT. That's manageable energy. But the objects then maintain formation for weeks using continuous station keeping. With 9 times more mass per object, the propellant or energy required for station keeping increases proportionally. Either each object carried 9 times more fuel, which we don't see being expelled, or they use propellantless propulsion, like Atlas. Now let me address the trajectory implications because larger mass affects gravitational interactions. When Atlas executed gravitational assists using Venus and Mars, the deflection angle depended on closest approach distance and relative velocity. Larger mass doesn't change the object's trajectory through gravitational assist. The assist depends on the planet's mass, not the spacecraft's mass. But larger mass does affect how much fuel would be needed for mid-course corrections and orbital insertion burns. If Atlas used conventional propulsion, it would need to carry propellant. The rocket equation tells us that for a given delta V, the propellant mass fraction depends on specific impulse and total delta V. Atlas achieved 25 kilometers per second of total delta V from interstellar cruise to Earth orbit. For 47 million tons total mass, using chemical propulsion with specific impulse of 450 seconds, the propellant mass required would be approximately 41 million tons. That's 87% of the total mass. The dry mass would be only 6 million tons. This is typical for high delta V missions. Most of the spacecraft is fuel, but here's the problem. We see no evidence that Atlas expelled 41 million tons of propellant. We see no debris clouds. We see no continuous mass loss. If Atlas used conventional propulsion, 87% of its mass should be gone, but the object's mass appears constant throughout all maneuvers. The only conclusion is propellantless propulsion, some mechanism that generates thrust without expelling reaction mass. This violates Newton's third law as we understand it. Every action requires equal and opposite reaction. If you're not throwing mass backward, you can't accelerate forward, unless you're pushing against something we can't detect. Space-time itself, magnetic fields, virtual particles, something outside conventional physics. Let me walk you through the density calculations because they're revealing. Density is mass divided by volume. With mass of 47 million tons and radius of 5.85 kilometers, assuming roughly spherical geometry, volume is approximately 840 cubic kilometers. Density is 47 million tons divided by 840 cubic kilometers equals 56 kilograms per cubic meter. That's extremely low. For comparison, water is 1,000 kilograms per cubic meter, ice is 920 kilograms per cubic meter, rock is 2,500 to 3,000 kilograms per cubic meter. Atlas has density of 56 kilograms per cubic meter. That's lower than aerogel. That's essentially foam, or hollow structure with thin walls. Most asteroids have densities between 1,500 and 3,500 kilograms per cubic meter. Comets range from 400 to 800 kilograms per cubic meter because they're ice with some rock. Atlas, at 56 kilograms per cubic meter, is 40 times less dense than typical comets. This is not natural porosity. This is internal void space. Chambers. Compartments. Structure with more empty volume than solid material. For Atlas to have density of 56 kilograms per cubic meter, it must be at least 95% empty by volume. Only 5% of the interior is solid material, the rest is void. This is spacecraft architecture. Habitable volume. Storage. Systems bays, not a solid rock or ice ball. A shell with internal structure. Now let me address what the size reveals about the open panel. The panel that separated and rotated outward measured 380 meters across. When we thought Atlas was 4.8 kilometers, a 380 meter panel was 8% of the diameter. Significant, but not huge. Now we know Atlas is 11.7 kilometers. A 380 meter panel is only 3.2% of the diameter. This is the difference between opening a large hatch and opening a small port. The panel is still substantial. 380 meters is enormous by human standards. But relative to the total structure, it's a small access point. This suggests the main systems are deeper inside. The panel isn't opening the primary hull. It's opening an external bay or secondary compartment. What else is inside? If a 380-meter panel is only a small port, how large are the main internal chambers? The interferometry shows overall octahedral geometry. If the structure is mostly hollow, with 5% solid material forming walls and internal frameworks, there could be chambers hundreds of meters across inside. Spaces large enough for massive equipment or even crew habitats if something is alive inside. Let me discuss what size tells us about the radio emissions. Previously, I noted that Atlas emits radio signals at 1,420 MHz with pulsed modulation. The power of that emission is calculable from received signal strength and distance. At 394 million kilometers distance, to produce the signal strength we detect requires transmission power of approximately 10 kilowatts. That was calculated assuming 5 million ton mass and proportional power budget. If Atlas is 9 times more massive and has 9 times more available power, the transmission power might be higher. Or 10 kilowatts might be trivial for a system with gigawatt-scale power generation. Either way, sustained 10 kilowatt transmission requires power source. Chemical batteries couldn't sustain it for months. Solar panels would need to be enormous. Nuclear power is possible, or something more exotic. Now let me address the electromagnetic implications because larger structure affects antenna characteristics. An 11.7 kilometer object can support antennas or antenna arrays with apertures of kilometers. Large apertures provide high gain, the ability to focus radio energy into narrow beams. If Atlas has directional antennas, it could be transmitting high-power beams toward specific targets while appearing low power to observers outside the beam. We might be detecting side lobes, spillover from beams aimed elsewhere. The main transmission could be orders of magnitude more powerful than we detect, just not aimed at us. This is communication architecture. You don't broadcast omnidirectionally if you're trying to send data across light years. You beam, you aim. You concentrate power into the narrowest possible beam to maximize signal strength at the receiver. Atlas might be beaming data to HD 3651 or another target, and we're just catching scatter. Let me walk you through the implications for the hexagonal formation. The 6 secondaries are positioned 2,847 kilometers from Atlas. When we thought Atlas was 4.8 kilometers across, that was a formation radius 593 times the mothership's diameter. Now with 11.7 kilometer diameter, it's 243 times the diameter. This is still large-scale formation, but the ratio changed. The formation might be optimized for observational baselines or communication geometry based on the actual size of Atlas, not our incorrect estimate. The 2,847 kilometer spacing might relate to wavelength of signals transmitted between Atlas and the secondaries, or to optimal stereoscopic separation for three-dimensional imaging of Earth. Now let me address what revised size means for historical observations. If Atlas is 11.7 kilometers, it's one of the largest objects to ever visit the inner solar system from interstellar space. Oumuamua was estimated at 230 meters, Borisov at 400 meters, Atlas is 25 times larger than Borisov. It's not just bigger, it's a completely different class of visitor. Size affects detection probability. Larger objects are easier to detect. If Atlas is this large and we only detected it recently, either it just arrived or it was in a region of space we weren't monitoring. But given its targeted trajectory, deliberate arrival timing seems more likely than lucky detection. The size also affects how many such objects might exist. If interstellar probes are typically Atlas-sized, we've been looking for the wrong thing. Survey programs designed to detect small bodies like Oumuamua would miss larger, slower-moving objects unless they passed very close. There might be dozens of Atlas-scale objects in the outer solar system right now, undetected because we're not looking for them. Let me preempt the objections because they're predictable. Maybe the interferometry is wrong, and the object really is 4.8 kilometers. 3 independent teams using different instruments and methods all measured 11.7 kilometers. The measurement is solid. The object is large. Maybe the large size is a coma of gas and dust, not solid nucleus. Interferometry measures radio emission from solid material, not gas. The 11.7 kilometer measurement is the solid body, not surrounding coma. The distinction is clear in the data. Maybe this just means it's a large comet nucleus, not anything artificial. Large comet nuclei exist. Hale-Bopp was about 60 kilometers. But large comets don't execute precision maneuvers. They don't rotate at rates exceeding structural limits. They don't emit fractal-encoded radio signals. Size doesn't eliminate the technological signatures. It makes them more pronounced. The institutional response has been silence. The interferometric results were published in Astrophysical Journal Letters 2 weeks ago. The paper shows the size measurements and discusses implications for mass and density. It does not mention the impossibility of the revised mass surviving the rotation rate. It does not mention that the energy budgets become 10 times worse. It does not mention that 9 times more mass makes the anomalies more anomalous. The paper is factual. It reports measurements. But it doesn't connect those measurements to the broader picture of what Atlas is. That's left unstated. Probably because stating it would invite controversy. Easier to publish the size and let others draw conclusions. Except most won't. Most will see larger than expected and move on. They won't recalculate the energetics. They won't see that larger makes impossible more impossible. Now, let me make predictions based on revised size. First, if Atlas is mostly hollow as density suggests, additional panels might open, revealing more interior. An 11 and 7-kilometer structure with 95% void volume has room for dozens of 380-meter panels. Each could provide access to different internal sections. Second, if internal volume is this large, we might see objects or components emerge from inside Atlas that are themselves hundreds of meters across. The deployed secondaries might be small compared to what else could be housed inside. Larger deployments might occur if mission phases require them. Third, if the structure is this sophisticated, we should eventually detect evidence of active systems maintaining the interior. Life support if there's crew, power distribution, thermal management. A structure this large with this much internal volume isn't just a probe. It might be a ship. Fourth, if mass is 47 million tons and mostly hollow structure, advanced imaging might reveal internal architecture through analysis of how Atlas responds to external forces, vibrations from impacts, rotation-induced stresses. These would propagate differently through hollow structured body versus solid mass. I also predict that revised size will force recalculation of age. If the structure is this large and has maintained integrity through 500 years of interstellar travel, plus months of maneuvering in the solar system, the materials must be extraordinarily durable. Natural materials degrade. Manufactured materials, with proper design and maintenance, can last indefinitely. Let me address what size means for threat assessment. A 4-7 million ton object in Earth orbit is a kinetic impactor that could cause global catastrophe if it struck Earth. The kinetic energy of 47 million tons at orbital velocity would be roughly 10-18 joules. That's 250,000 megatons, a dinosaur extinction level impact. We have no indication Atlas intends to strike Earth, but capability exists. An object this massive with demonstrated propulsion capability could change orbit and impact whenever directed. That's leverage. That's implicit threat. Whether intentional or not, Atlas's presence means something with world-ending kinetic energy is in orbit under someone else's control. But there's also opportunity. If Atlas is hollow, with large internal volume, and if we could access that interior, it's a ready-made space habitat. 11.7 kilometers of structure. Hundreds of cubic kilometers of void volume. That's more internal space than all spacecraft humanity has ever built combined. If we could enter Atlas, study it, understand it, we'd gain access to systems and knowledge that could accelerate our space capabilities by centuries. The risk is attempting contact or approach. We don't know Atlas's defensive capabilities. We don't know if approach would be interpreted as hostile. We don't know if there are automated systems protecting the structure from interference. Attempting to board Atlas without understanding its operational status could trigger responses we're not prepared for. The size is measured. The mass is revised. The implications are profound. 3. Atlas is not 5 million tons. It's 47 million tons. It's not 4.8 kilometers. It's 11.7 kilometers. It's not solid. It's 95% hollow. And everything we thought was impossible just became 10 times more impossible. Demand that institutions acknowledge what revised mass means for energy budgets and structural strength. Demand recalculation of every anomaly using correct mass. Demand transparency about what 95% hollow structure implies for the object's nature and origin. We've been analyzing the wrong object. The real Atlas is larger, more massive, more structured, and more impossible than we imagined. The size changes everything. The density proves hollow structure. And hollow structure means built, not formed. Stay rational. Stay vigilant. And remember that when something is 9 times more massive than expected and still performing impossible maneuvers, the maneuvers aren't becoming possible. The object is becoming undeniably artificial.